Filtaquip has over 40 years of experience in supplying products and services into the global mining, metallurgical and chemical industry, and are at the forefront of innovation in electrowinning and dewatering technological advancement. Situated in Johannesburg, South Africa, we are dedicated to offering first-world filtration technology to the global metallurgical industry. Our in-house designs and manufacturing of innovative products have become the standard for base metals, precious metals and the coal sector, providing the highest possible quality. Filtaquip is the global leading supplier of filtration equipment, turnkey plants, and services for the precious metals, base metals, and coal industries in solid-liquid separation. Other important business functions include customer service, after-sales and repairs and upgrades. Filtaquip's philosophy focuses on the relentless search for harmony between the production requirements of a modern company and environmental protection. With the ever-increasing demand for electric vehicles, as well as countries moving towards renewable electricity, there has been a huge increase in demand for high-purity base metals, namely copper, nickel, and zinc. Electrowinning has proven to be one of the most efficient means of producing such high-purity base metals. Filtaquip showcases the necessary equipment required to help achieve these goals in the electrowinning sector. We use robotic TIG welding as opposed to laser welding to weld the stainless steel sheet to the hanger bar. By robotic TIG welding, we achieve a perfect weld on every cathode. Robotic TIG welding allows us to achieve greater penetration and accuracy when compared to manual welding, thus ensuring that all welds are structurally sound. Our cathodes are fabricated from the highest grade oxygen-free C1-0-2 oxygen-free copper sourced from MSS India. This results in better conductivity due to less resistance in the bar as there are minimal impurities present. Our copper bars have been tested to provide 101% conductivity consistently throughout the bar. Our hanger bars are co-extruded with stainless steel 3-1-6L. Our process produces direct mechanical contact between the copper and the stainless steel, providing consistent contact throughout the bar, allowing for even distribution of current and minimal resistance in the entirety of the bar. We prefer not to use explosion bonding, as this often leads to air pockets being formed along the contact area. This results in inconsistent contact and may result in uneven distribution of current and increased resistance in the bar. This will consequently impact the quality of the final product. Furthermore, explosion bonding requires an explosive material that typically releases potentially harmful gases into the working environment. Our cathode blades are sourced from Filtaquip, ensuring that the highest grade material is used for the manufacturing of our cathodes. We offer hanger bar replacements, as this will be preferable in instances where the blade is still in good working condition, but the copper bar has either degraded or is not conducting well. This option leads to reduced wastage of stainless steel as the blade has been reused. Furthermore, this reduces your capital expenditure, as most of the cost of a cathode is in the blade itself. Cathode stripping machines, or CSM. This results in a controlled consumption of electricity, and efficient washing leads to less wastage and is safer handling than manual stripping. Anode insulators. These provide rigidity to the anode, preventing bending. Bending results in the formation of nodules on the copper plates being formed. Should the nodules contact the lead anode, it will lead to short-circuiting. Since the anode has better structural integrity than the insulator, it results in a longer lifespan for the anodes. This means that less lead would need to be discarded, which is beneficial for the environment. From client experiences, our insulators result in high yields of copper per cathode. Cathode edge strips prevent the buildup of copper on the sides of the cathode. If these strips are not used, the copper may build up around the edges, which encloses the steel blade within, thereby making it virtually impossible to remove. We supply 100% virgin polypropylene edge strips, which are machined to fit the blade perfectly. This results in no buildup on the edges of the blade. The dangers of tailings dams have come to the forefront over the last few years. One such case, over 250 people lost their lives when 11.7 million cubic meters of mining waste surged through the town of Brumadinho in Brazil in 2019. The tailings waste was not managed effectively and caused failures within the tailings dam, which released harmful waste onto the residents of Brumadinho and the surroundings. With tailings dam failures such as these, pressure has been put on mines to reduce their volumes of waste and at the same time reducing the impact on the surrounding environment. Metal mining companies are specifically looking for a solution that enhances solid-liquid separation to recover metals and at the same time reduce their tailings waste. Filtaquip's philosophy focuses on the relentless search for harmony between production requirements of a modern company and environmental protection. Filtaquip's complete dewatering solution solves these issues by creating a solution that dewaters the slurry waste and creates a filter cake which can be dry stacked, reused or sold, depending on the application. This dewatering system can be customized and applied to most mine tailings waste. It is important to note that dewatering is not intended to treat the slurry, it only separates the solid and liquid components so that it is easier and more cost-effective to handle the separate phases for final disposal. Once the slurry has been dewatered, both the solid and liquid components may contain contaminants that will need to be treated separately. Before the dewatering process can begin, slurry has to be conditioned via chemicals such as iron salts and lime, or organic chemicals such as coagulants and flocculants. In the Filtaquip dewatering solution, we use a flocculant plant which conditions the slurry in the thickener using hydrated flocculant which promote the agglomeration of fine particles present in the slurry, thus creating a flock, which then settles to the bottom of the thickener. While filter presses are great pieces of dewatering equipment, they are best used on feed slurry concentrations of about 50 to 60% solids. Lower solids concentration requires feeding the slurry through a thickener first. Thickeners are best described as large settling tanks, preferably used as a primary dewatering step. Here, feed slurry enters at a much lower solid concentration, typically around 5 to 10% solids by weight. Using gravity and polymers, thickeners cause solids to build up at the bottom of the tank, where they can be discharged from the base of the unit as sludge. Filtaquip manufactures three types of thickeners. They are the high-rate, vertical, and the Filtaquip thickeners. Vertical thickeners use the principle of static decantation for a natural settling of solid material, while both the high-rate and the Filtaquip thickeners use a rake mechanism that sweeps the sludge, through rotation, to the central outlet. Our thickeners also utilize a specialized feed well design that allows for improved sediment discharge, thus decreasing short-circuiting. Determining which type of thickener is best for your application depends on your dewatering needs, driven by maintenance costs, material types, and to what extent you wish to separate solids and liquids. When used in combination with each other, a thickener and filter press can recover 90 to 95% of your water as clean water. The remaining water will discharge with the solids from the filter press. The sludge at the bottom of the thickener is then fed to the filter press. During the filter press fill cycle, the slurry is pumped into the filter press. Solids build up on the filter cloth, forming the filter cake in the recess of the plate. The filtrate, or clean water, exits the filter plates through filtrate ports, which then flows into a launder. As the filter press feed pump builds up pressure, the solids build within the chambers until they are completely full of solids. This forms the cake. The filter cakes release when the plates are full of solids, and the cycle is then complete. Also, many higher capacities filter presses use fast-action automatic plate shifters which speed up the cycle time. Filtaquip designs its filter presses for fully automatic, 24-hour operation in a harsh environment such as metallurgical or chemical manufacturing plants for wastewater treatment. There are two main purposes for sludge dewatering. These are waste minimization and achieving overall cost efficiency for disposal. Additionally, dewatered sludge can be handled more safely and can reduce health hazards. Some sludges have great beneficial reuse and can be sold. Generally, both the public and private sectors are required to dispose of sludge in a manner that is approved by regulatory agencies and is in line with their own organizational requirements and environmentally safe policies. Sludge dewatering is typically focused on reducing the weight and volume of the sludge so that disposal costs, including transportation, are kept to a minimum. Water removal is the primary means of volume reduction before waste can be treated or disposed of in the most economical manner. Filtaquip offers pilot testing either on-site or at our premises in Johannesburg, South Africa. Filtaquip has extensive experience in designing and operating pilot plants for slurry filtration test work. Coupled with experienced personnel and proven equipment design, we deliver innovative solutions to meet your requirements. You can contact us via our website for more information about pilot testing. Thank you for your time. That concludes the Filtaquip presentation, and now we would like to open up the floor to any questions you might have on either the electrowinning or dewatering solutions that we offer.